Hello everyone, in today's session we are going to perform univariate linear regression analysis in Excel. For that I have created dummy data as you can see on the screen. So this is my dummy data where salt intake is denoted by X, which shows my independent variable, and blood pressure, which is denoted by Y, which shows my dependent variable. Next, for univariate linear regression analysis, we have this particular equation: y equal to b0 plus b1 multiplied by x plus some error. Over here b0 stands for intercept and b1 stands for slope, and that error component. So when we get this predicted value of y, we will automatically get this error values. Now to get the value of this b0 such that intercept, we have this particular equation, and to get the value of slope we have this particular equation. Within these equations we need to find out the values of x bar and y bar. Over here x bar and y bar stands for average values of respective variables. So using this particular equation I have created these four columns and their values are as shown on the screen. Next, using these four columns I have figured out the value of b1, that is slope, which is 4.70. Then using this particular formula I have figured out the value of intercept, which is 105.42. Now using this particular equation y equal to b0 plus b1 into x, if we put the values of respective variables that we have got, the equation will become y equal to 105.42 plus 4.70 multiplied by x. And now using this particular equation I am going to get predicted values of blood pressure, that is predicted value of y variable, which is as shown on the screen. Next, to figure out how well my linear regression model is performing, I need to figure out the values of r square and adjusted r square. Over here the difference between r square and adjusted r square is, in case of r square, if we are going to include any irrelevant independent variable, its value is going to be upward, means its value is going to be increased. And in case of adjusted r square, if we are going to include any irrelevant independent variable, in that case it is going to penalize for it, and in that case the value of adjusted r square is going to be down. Hence, whenever you are working with linear regression, always make sure that to assess how well your linear regression model is performing, you look at adjusted r square value. Now to figure out the value of r square, I will need the values of sum of square due to error and total sum of square. Again, sum of square error has this particular formula and total sum of square has this particular formula. Using these formulas I have figured out these two particular columns. When we put these values of SSE and SST in this particular equation, I will get the value of r square as shown on the screen. And when we put the value of this r square and number of sample size and number of independent variables, I will get the value of adjusted r square as shown on the screen. As this is the augmented data, over here my model is performing very well, and hence my r square and adjusted r square values are nearer to 1. Let's see, if we are going to run this univariate linear regression analysis in R, what will be the values. So as you can see on the screen, I will get same linear regression equation that we have got in Excel. Over here you will be able to see that this is the linear regression equation in Excel, and same equation I have got in R, and I have got same value of SSE, SST, r square and adjusted r square in R script. Over here R script has rounded the values to 1. Next, if I am going to perform same univariate linear regression analysis in Python, I am going to get the same linear regression equation as shown on the screen. So this is the equation that I have got from Python, and this is the equation that I have got from Excel. And same way I have got the same value of SSE, SST, r square and adjusted r square. That's it for the day. Thank you everyone for watching this video.